Ladies and gentlemen, it is 3 p.m. Time to speak lithography. Good afternoon, everyone. I see a lot of good friends here. Hello, Patrick. Hello, Arseny. Hello, Martin. Well, hello, Arseny. Yeah, good to see you. Hello, everyone. Where do we start? Let's start. Let's talk lithography. On July 3rd, we discuss lithography. Success stories like ASML generate tens of billions for the European economy because without it, your smartphone could never be built.
The demand for our product is still pretty healthy. It's in the data centers of the Amazons and the Googles of this world that are currently being pressed because the data traffic is enormous.
Light is used to etch tens of billions of components into each tiny chip. It's like a giant photocopier on steroids. I want to understand the supply chain needs from different lithography equipment manufacturers, companies like ASML, Heidelberg Instruments, SUSS, EVG, Obducat, Nanoscribe, Multiphoton. We need to scout opportunities for the photonics sector. CO2 lasers for extreme UV, excimer lasers for deep UV, laser optics, maskless lithography tools, nano-imprint metrology solutions, mask aligners. This is one of the hottest topics that we have in EPIC. Even beyond that, as a fan of optical systems, there is nothing more beautiful than the EUV stepper from ASML. It is not just a machine, it's a work of art. So let's align at 3 p.m. on Friday, July the 3rd, during our next EPIC Online Technology meeting on lithography. Sign up here to participate or follow us online in the EPIC YouTube channel because in this business, success is in the detail. Thank you very much for being with us today. Today we only have 6 meetings to go. This is number 33 of the EPIC Online Technology meetings. I think Anna and me are fantastically tired, but also super amazed of the amount of interest that the online technology meetings are bringing for the whole industry. And we love the feedback we keep getting from all of you. We keep going. So we will continue with EPIC Online Technology meetings after summer, but these are the 6 topics that we have left today. Lithography, but we're going to talk polymer optics on Monday, a great meeting already lined up, specialty optical fiber with companies like Valeo or Siemens. Then afterwards, horticulture, and we signed an agreement with the AIPH to have the end users in the meeting, microscopy with top microscopy manufacturers. We finish with all the car makers talking to us about autonomous driving. So there is still a lot to do in the next EPIC Online Technology meetings. I would like to say, most important, thank you, EPIC members. Thank you, the European industry. I'm getting so overwhelmed by the amount of membership forms that we're getting. I think we are now 585 members. We are very close to the 600 line. Thank you so much for the interest and for supporting us. Without you, we cannot do anything. And I continue to say thank you. I cannot stop. Thank you, the amazing team that is behind the scenes in every online technology meeting. These people are working non-stop from Monday to Sunday, from early morning until late evening. And I don't want to sell membership anymore because it sells itself. I just want to say that if you are looking for people to help you identify the best events for you to attend and promote your technology, the best people for you to interact as a supplier or partner or potential customer, the money sources for investment, finding a job in photonics. Always visit jobsinphotonics.com, the biggest website to find a job in photonics today. Or you're looking for market reports. I don't know, Anna, how many market reports we have now. I think 17,000 view graphs, all available for free to all our members. Thank you so much for supporting the association. But today is a very, very important day, Anna. Today is lithography. For many years, because I used to work at TNO and I used to do a lot of projects with ASML and SAIS. For many years, I always wanted to bring all the key lithography companies together and identify what we can do together. This meeting today has been the result of a lot of dreams that come true today. I would like first of all to acknowledge the sponsors today, starting with edgewave. Whether you're looking for lasers for any particular application, especially for the lithography sector, do not forget to check edgewave as one key supplier of Obducat. If you're looking for equipment for the patterning and surface structuring, either it is for MicroOptics or for semiconductor manufacturing, Obducat has the right solutions for you. And Heidelberg Instruments. I love these guys. In one of the most beautiful cities in the world, Heidelberg, they manufacture maskless litho, so laser-based lithography system for micro-optics. It's great to have the support of the 3 of them. Without them, it wouldn't be possible. But now I would like to give the floor to the excellent co-chair, Dr. Ana Gonzalez. Doctor, what is in the floor today?
Thank you, Jose, for this nice introduction. So yes, we have many companies doing equipment as end users giving the talks, but well, this is not the only companies that we have here today. They are going to trigger the discussion, but we have the complete representation of the supply chain, because this is exactly what we need, right? In order to foster collaboration, to see new businesses between our companies. So we have the end users that are going to tell us about the challenges, what they want to be improved, what are the future needs in lithography technologies. In this case today is very nice, because we have the services providers of wafers and manufacturers of photonic integrated circuits that are the end users. They are the ones that are going to ask the companies making equipment what are their needs. And for this, we have all the different companies that are making the different kind of equipments, inkjet printing, ALD, manufacturing automation, high resolution 3D printing, nano-imprinting lithography, micro-nano patterning surfaces, and also maskless lithography and semiconductor optic manufacturing. And also, in order to cover the needs of these companies doing the equipment, we have all the other supplier of components and developers of component technologies for laser alignment, beam shaping, imaging, lasers for lithography, also materials, photoresist, adhesives, UV sources, optics, coatings, mask plate processing, and of course, lithography and R&D. Just a final remark to highlight the pylon lines with which we are collaborating. The JPIX pylon line for indium phosphide peak production, a fabulous pylon line for freeform microoptics manufacturing, and also a PIXAT for packaging, and in this case, in this meeting, for manufacturing automation. And well, this is all that I had to say about this slide. Back to you, Jose.
Many Epic members, Anna, keep asking, why is my logo not there? I would like to remind all of you that this slide represents only the companies who registered for this meeting. Anna and I never forget any of our 585 members of Epic. I would like to say hello now to the people who are watching this meeting in YouTube. Hello, YouTubers. If you have any question, please put in the chat. But most important, if you want to get in touch with any of the participants today, all you have to do is send me an email, jose.pozo@epic-aso.com. This is also valid for the people in the Zoom channel. If you want to get in touch with each other, of course, use the private chat. But if you want me to make an introduction, all you have to do is send me an email, jose.pozo@epic-aso.com. I love connecting the industry. And that's it. That's all we had to say as an introduction. Let's leave the floor to the people who are driving this business. And there is no better way of starting a meeting on lithography than going to Neuchâtel and talk to our friend Reinhard. Reinhard, CEO of SUSS MicroOptics, thank you very much for accepting the role of being the opening speaker of this beautiful afternoon. We want to hear a little bit of SUSS and also a little bit of introductory talk to this fantastic meeting. The floor and the attention of everyone goes to Neuchâtel, goes to your MicroOptics, goes to you.
Oh, can you hear me?
Loud and clear.
Loud and clear. Jose, what a pleasure. I'm still so proud of you for these 24 hours. Okay, so I want to start differently, not with SUSS MicroOptics. I want to start with my hero, because modern lithography started with a Swiss guy, Joanneum. He was working at Fairchild 1957, and he had the glorious idea, because transistors were done one piece after the other. And he said, oh, I could put many transistors on a small piece of silicon, the planar process. And this was the big game changer. So Fairchild started to have the first transistor. Whenever you're in Silicon Valley, in Mountain View, there's a wonderful semiconductor history museum. Go there, visit your life, see all the computers you had in your life. So what happened then, the Fairchild guys, there were 8 founders, and there was Gordon Moore and all those guys, Bob Noyce, and they founded 65 companies based on the planar process. And today we have on a wafer, I don't know how many trillion of transistors we have on a big wafer now. And this is a big thing, the planar process. So he's my really hero. At the very beginning, lithography was very, very difficult because they had to put a mask on the chip and in contact, and they got a lot of dirt, and they had a very bad yield, and they had a resolution which was tremendously bad. So on the right side, you can see they started with a 120 micron resolution, and the first Intel chip in 1971, it was a little bit better. They were down to 10 micron, but they had up to 95% crap. They had this ruby lit mask where typically women had to cut out from the mask the design of the chip. So 1980, there was the stepper came in and projection system. So the mask aligners, which was still my mother company, Carl Zeiss, was doing, and they had a small market share, they were phased out within several years. So who came in? The stepper. There was Nikon, there was Canon. And as you were at TNO, I guess you were not at that time at TNO. We were all at school. But Philips once at ASML had big problems. They needed 30 million from Philips in 1992 or something. And Philips said, oh, this lithography, this will never give anything. And they hesitated to give it to them, but it was a big success. My step in lithography was 94. I was a postdoc in Neuchâtel, and the Zeiss guys, Johannes Wangler and Edgar Pieper, came and said, oh, you know, we have a laser now. We need diffractive optics for the stepper. And everybody said, diffractive optics never worked. You know, that's a good for nothing technology. And now this will never work, but we tried it. And the formula was very simple. An excimer laser has a very bad laser profile. But together with a diffractive optical element, you could shape the light in any form, laser beam shaping. And this was one of the key inventions who really changed lithography, because they could do pupil shaping and they could reduce strongly the aberrations and all the effects, diffraction effects in the stepper. Later in 2009, we were preferred supplier for Zeiss, doing a lot of research with them. And then Johannes Wangler said, oh, we put a MEMS mirror in the stepper. And I said, never, this will never work. But ASML and Zeiss made it happen. The flex ray, if you look for a stepper today, you see that from the pulse compression to the pupil shaping, the reticle is a phase shift hologram. It is a hologram as Adolf Lohmann invented it, a good for nothing technology, but now in all the stepper, you have holograms everywhere. MicroOptics, this is what I'm good in, did a good job to improve the stepper. I'm almost finished. Not the Moore's law, you know, but the not Moore's law says every 4 years, the price of a leading edge lithography tool doubled. So it started with 10,000 for a mask aligner, and I don't even know how much you have to pay to get the latest EUV stepper from ASML, but it's very expensive. So what did lithography do for us? Jose, I take your question already. So every year, 30% cheaper. What did this mean in our life? 2005, MSD chip, 120 megabyte, 120 euros or dollars or whatever. Today, the same money buys you 512 gigabyte, 4,000 times more within 15 years for the same price. Nobody did ever better than lithography. Mask aligners were not that. We still use them a lot for imprint lithography, for example, or for very uncritical steps. SUSE still has 6,500 mask aligners installed, and every year some 100 come. And I have to do a bit public relation because I'm in the SBI Advanced Litho Committee, and it's a call for papers, and we open the conference for imprint, for nano-imprint, for everything which is related to lithography. I have 5 seconds left to say thank you very much. It's always a pleasure, because I got my timer here, so you can see the timer. So thank you.
Okay, thank you very much, Reinhard. A great presentation as always. Okay, so comments, questions for Reinhard?
That's no question.
They will come. Reinhard, then, I mean, you have been talking about a lot of lithography equipment, and you are a user in this case of the lithography equipment. Could you make, what could be improved? What kind of, I mean, in terms of lasers or in terms of other kind of components in these kind of machines?
So I'm not only a user, we supply a lot for this technology, and I was deeply involved in all the illumination side from the step. I guess no technology improves so much from one year to the other. So I'm every year on the SPIE lithography, and every year something dramatically has changed. We're now on 3 nanometer. So no technology has changed our life so dramatically on the technical side. Everything gets more expensive, but as a matter of fact, microchips, computer chips for cars, everything gets cheaper. So I don't see that there is something dramatically that we could improve, but maybe my colleague from ASML, he has the absolute news, what is now dramatically better than last year.
So let's ask Bedwyr from ASML. So yes, what do you think?
What can be done next? Well, I guess from the presentation that I'll give you an outline of what we do. I think I'd agree with Reinhard that there's no one thing you can do to really push this. It's about now squeezing the last bit of effort out of all sorts of aspects of the litho. It's not just the printing; it's also about measuring, but also it's about computation as well. It's combining all those three together. So it's more about the holistic approach now.
Okay, thank you. And maybe we can talk a little bit about the lasers that are used. We have here, I can see someone from Nanoplus here. Sorry, I cannot see. Masoud, hello, how are you?
Hello, good, thank you. Yep.
Would you like now to introduce what is Nanoplus doing and what are your interests in this kind of meeting in lithography?
Okay, I mean, for the moment we are using several type of lithography. One type mostly we are using now, it's mostly e-beam lithography at the moment. It's I think everybody knows it's a little bit slow and difficult, and in the same time, we also use light lithography, but not so often. And for the moment, I just want to see what lithography can offer for future. Maybe if we can move from e-beam lithography, which is quite difficult to handle, and to do a little bit easier one. But that is what I'm interested in.
Okay, thank you. I hope this meeting will tell you about this. Okay, we have, in the meantime, we got 2 questions. So Benjamin from Infineon. Hello, Benjamin. Would you like to proceed with your question? Benjamin, we cannot hear you. But I see you are not, no, now you are mute.
In the bottom left corner of the Zoom window, next to the mute button, there is an arrow up. Click on it, and there are different options for the microphone. Just select one of them should work.
Okay.
Yes.
Don't worry, Benjamin. No, we cannot hear you. Don't worry, Benjamin. Sharara will take care of provide you a dial number. And in the meantime, we can move because we have another question. Carlos Dominguez, hello. How are you? My silicon nitride foundry of my thesis.
Hello, Anna.
Hello.
How are you?
Very well, and you as well, I can see. So,
yes.
Do you mind? Well, maybe first you can introduce what is the CNM doing in lithography, and then you can ask your question.
Yes, thank you. We are a research center that are dealing mostly with microelectronic technology, but some time ago we started also with photonics, with the development of photonics technology for multi-project wafer. We belong to EPICS Fab Alliance, and we are dealing also trying to solve in some cases the problem how to go from millimeter scale to nanometer scale. And because my question, how can we obtain a lithography equipment that can build or can join both excuse me, areas of sizes of the that we meet in every photonic circuit.
Okay, so this is, I understand this is a general question for all the audience. So, well, yes, Reinhard.
Yeah, so this is like, I want to drive 300 kilometers per hour with my car, and I want to transport all my furnitures with a car. It's not really possible to get all things together. Yes, you can do 3D imprint. Yes, you can do very sophisticated molds. Yes, you can do quite some things, but you want like to have a Porsche which can transport 10 tons. Huh? It will be a monster car. It will drive 300 kilometers per hour, but you will not find a parking. Sorry to disappoint you.
No, yes, it's okay. And then we have also Arseny having the one question from Wave Optics.
So Wave Optics, at Wave Optics, we produce augmented reality displays using diffraction gratings, and those gratings can be of very complex shape actually, and right now we do it through nano-imprint lithography, as most of our friends or competitors, let's say, but those shapes are really complex, and even creating them in the master mold for the nano-imprinting is a big challenge. So in my opinion, the current lithography technologies, which were originally targeted for semiconductor industry, are actually not exactly tailored to achieve those kind of shapes. So I guess my question here is, what can be done? What kind of advanced techniques can be used to create more complex nanophotonic 3D shapes?
I would say it is a question of how many people need that, because in semiconductor industry, you can design the most sophisticated machines, which are incredibly expensive, because there's a big need on the planet. What you want to have, there are not so many people who want to have it. So an equipment manufacturer will have a very limited resources to support you with your customized solution. But if it becomes mainstream, you will get the solution. So I work together with SUSE and develop the tools that you need more precise, but there's no miracle, because if you say I want to print 200 wafers per year, then it's difficult.
Yes, sure. I mean, I fully understand, but obviously this is also a business opportunity for the equipment manufacturers, because this field is expanding, and
Absolutely.
we do need providers of the tools which would be able to achieve quite advanced requirements for the nanofabrication.
Arseny, Wave Optics is one of these companies that we need to help, because it's a success story of European industry. We need to help you. I think my friends from Katz can help you. Paul, what do you have to add to this?
Hi, Jose. Hi, Arseny. I will have a talk in a few minutes to show you some of the solutions maybe that you want to look for, because our technologies are not the high volume semiconductor technologies that we're using, but are really dedicated for these small specialty applications. So please watch out, and maybe we can talk about this later after my talk.
Of course. And now we go to Infineon, or semiconductor giant today, because I think Benjamin has a working microphone at the minute. No, he doesn't. We need to find a way to give you. I will send you a microphone right now, because I have a question in YouTube, Anna. I have a question in YouTube for my very good friend Pierre-Marie Coulomb from University of Bath. The question is both for SUSE MicroOptics and for ASML. So I'm going to go first to Reinhard, then to Bedwyr. And it's a good question. It says, general question, steppers had and are having major impact in the world of lithography, what other tool will have a significant impact in the future? Nano-imprint, maskless, others?
Yeah, this is a very interesting thing. On every advanced litho, there's a new nano-imprint tools. Canon invests millions and hundreds of millions, and they show that they get down to less than 20 particles, and they can really do for memory and for everything because they bought molecular imprint and they have SUS, whatever. But the problem is that the mainstream technology is so strong that nano-imprint is always running behind. Maybe one day a nano-imprint will have the big impact, even in semiconductor, but for today, it's still a niche market. What I think where nano-imprint is good is print on CMOS image sensors.
I think nano-imprint has made a huge impact because now we can do wafer level replication of very, very high-end optics are compatible with many other technologies. And you have a success story entering the automotive market with this. You are a person I really look up to. Thank you very much for being with us. I'm going to ask now ASML, and then I'm going to give the floor. But first I have to say, it is so amazing, Bedwyr, to have ASML in EPIC. Thank you for being a member. It gives us so much reputation. So what do you have to say about this? What is the next big thing on lithography equipment?
Well, I think I'll give you a presentation on what the current big thing is, and from that we can take it from there. So
fantastic.
Let me share my screen.
All the way from Eindhoven, one of the most beautiful cities in Europe, all the way here in Noordwijk, all of us in the Netherlands. Let's talk lithography, the way that money is made. The floor is yours.
Right, okay then. So I'm one of my concerns I have now is how do I follow Jose and Reinhard's presentation? So I'm not too sure I can be as exciting, but let's see what I can do. So good afternoon, everyone, and thank you to EPIC for the invitation to present today. So as I said, I'm Bedwyr Humphreys. I'm in the Strategic Business Development Group at ASML. I'm a bit of a newcomer at ASML. I joined last year and I spent the majority of my career in 3.5 semiconductors, most of that in photonics. I think one of my colleagues presented at a recent EPIC photonics event on the tools that we have. So given the time we've got today, I'm going to focus more on the general overview of what we do, what's important to us, but also how we leverage a strong innovation networks and how essential they are for continued industry progress. So let me see if I can move on to the next slide. Quick disclaimer there. And then, so a brief snapshot of the products that we have, and highlighting here the NXE 3400C, and that's our latest EUV tool. Got some performance specifications there, and I hope they speak for themselves really. So 13 nanometer resolution, 1 nanometer overlay. But one of the things that I wanted to point out here was that the key to any successful product is not just the raw performance, but also it's the productivity. And we've worked really hard to get this up to a level where now EUV has been adopted by our customers because it offers a clear value proposition compared to multi-patterning. So of course, we continue to drive that productivity number, and it's a clear focus on that. And I guess, as with the 0.33 NA tool, which is today's tool, that's enabling 7 nanometers and 5 nanometers. Then the next generation 0.55 NA tool will enable the 3 nanometer and beyond nodes as well. But hey, it's not all about EUV. As our, I guess, highly successful immersion lithography tools are considered, I guess, today the workhorses of the industry, and already today deployed in 7 nanometer nodes. But again, one of the key successes for this platform, again, is continuous improvement in performance and productivity, and also closely aligning the tool's capabilities to seamlessly integrate and match it with the EUV capability as well. So essentially on these two platforms, it's all about continuous innovation. There's no way that we can stand still. And of course, finally, on this slide, it's not all about 7 nanometers and beyond. And our tools are also used in emerging markets today. And I guess what we see is as these markets and applications start to demand greater performance and productivity because they're maturing, so our tools become more attractive given the production track record that we've offered. But yeah, these results I think are pretty impressive. Having been with the company only a few months, I'm blown away by the capabilities. But it's not just about the lithography tools, and we couldn't achieve what we achieve if it wasn't for holistic lithography, which is the approach we take. So, as well as the image, the scanners, we also create inspection and metrology tools. We've also got an extensive in-house capability on computer modeling and simulation. So when we combine these three elements, so what it does is creates an ability to detect and control sources of error, enhance the process window that that we're operating in, and ultimately that means we can focus on identifying, eliminating, mitigating sources of error, which allow us to meet our customers' roadmap requirements. So things like edge placement error, and also resolution needs. So the point here is that when you see and hear those wonderful results being achieved, just be aware that those come through a holistic combination of imaging, measuring, modeling, and each of those elements being continuously improved and refined on a daily basis. So I guess as this is a lithography panel, I don't need to emphasize so much that lithography is so important to semiconductors and photonics. But the point I wanted to make here was that although I guess EUV tools are seen as the rock star equipment that generates all the headlines, the ASML business is still built on a broad platform of tools, and with deep UV immersion tools still generating more than 50% of system sales and over 80 systems sold last year. Of course, this is still closely followed by the EUV sales, but nonetheless, having a wide portfolio of tools is important to us. So it allows us to offer enhanced lithography capability across a broad range of applications. And in terms of what are those applications today? Well, the important ones for us are AI, 5G, high performance computing, autonomous driving, big data, and ultimately all of these are driving the logic market, and that continues to shift towards the next nodes. That's an undeniable fact. But it's not just compute. We're also seeing the same happening in DRAM as well. But I guess creating the performance that we now achieve doesn't necessarily come cheap. And the focus on innovation that we've made in the last few years. So last year we spent around about 2 billion on R&D. But I guess the emphasis here is that it's not just on internal R&D. We work very closely with a number of partners. We're very privileged, I guess, to be part of such an impressive open innovation ecosystem that ultimately helps to drive semiconductors and photonic industries towards greater success. So I guess from this, I'd like to say that we're keen to encourage and support innovation. And I suppose we have a number of ways of looking at it, which can range from working with and mentoring startups, all the way through to having an investment relationship, maybe with key suppliers. So the final question is, where can photonics help ASML today? Well, photonics is already, it's essential to ASML's business. And I guess there's not one area I could point to. But what I should say is that we're not using photons just for imaging. Photonics is being used for sensing, positioning, correcting. So, there are a wide range of opportunities there. So, in particular, I think we're interested in supporting, developing and using a wide range of technologies from the ecosystem. So I guess I should reach out and say, please feel free to get in touch with me. We're keen to speak to anyone within this industry. And therefore, I guess to conclude, I should say that ultimately, it's only by working together to the mutual benefit of all parties that we can ensure success, and in particular, photonics success. And I think, in my opinion, photonics will play an ever-increasing and pivotal role in our daily lives. So thank you very much for listening.
Thank you very much. I am amazed. It's a special day. Last week in 24 hours, we also had the presentation from ASML, and I saw the 2 billion euros spent on R&D. I didn't want to comment them because we had the pressure on time. Today, we have a bit more time. So this 2 billion euros is a lot of money. We want to help you spend it. I had already a couple of ideas of potential collaboration, but if you could tell us, one challenge, I call it the Santa Claus Christmas list, as something that you think your R&D team would be super happy of having from the photonics sector.
I think there's there are a number of challenges, I guess, that ultimately face us, but it's about focus now. It's about not necessarily being distracted by other technologies. So focusing on the 0.55 NA tool, and that means bringing the ecosystem together. And it's how do we partner? How do we partner across sector to really, again, bring a virtual supply chain, virtual collaboration across the whole industry. So it's less about a specific challenge, and it's more about that integrating of businesses together, and how do we enhance that holistic lithography aspect? Because it's not just about just the tool. The computation side, you would be amazed by the level of computation that goes into this, and how much that really improves the level of resolution that you can achieve.
For me, having ASML in EPIC has been key. First of all, I have so many friends working there. So it has been another chance for me to meet them constantly. Also because, as I said before, the EUV stepper that is just behind you is perhaps one of the most beautiful optical systems, but also one of the most complex optical systems that fully works reliable 24/7. Are there any questions from Bedwyr? Let me see if I have something in the chat. There's a very strong debate going on in the chat, but they have a question all the way from Marco from Size Getters. Marco, I think we can hear you.
Hello. Can you hear me?
Loud and clear, and we love your beautiful glasses. What's on your mind?
So thank you for let me speaking. I work for Size Getters. Size Getters is a company making, among other products, neg pumps, which are vacuum pumps chemisorbing gases. So they are basically a very compact and a very effective way to remove gases in a vacuum system. They are a standard in particle accelerators and other applications. So my question for Bedwyr is, what are the main factors to optic degradation? And other trends requiring better purity of atmosphere on lithography optics, and which are the typical operative condition of optics as far as gas is concerned?
It's certainly a very good question, and I guess as you're aware that there is a gradual coating of some of the optics within the vacuum chamber as the tool is used. Now, in terms of the specifics of the question, my background is actually in plasma equipment and plasma physics, so I could probably make a stab in the dark at answering the question and offering suggestions on gas flow dynamics. But I think at this point it's not something that I could answer with any level of assurity. So maybe we could take this offline and have a discussion, or I can put you in touch with the right people. But for me to take a stab at that one might not be the right way.
Bedwyr, Europe right now has 3 revolutions. On one, you are extremely driving it. It's a revolution of photonic integrated circuits based on indium phosphide, and actually is driven by many people in Photon Delta, in Eindhoven, and you have a pivotal role there. Europe is living another revolution. It's the revolution of micro-optics. Right now, we have really the best micro-optics being manufactured in the world with European technology. You're going to hear later from 2-photon polymerization. You already heard from SUS Micro-Optics. You will hear from EVG. We hear maybe from Joanneum, but also nanochrome, morphotonics. Everything is aligned to provide the best micro optics. I don't know, Rolando, you want to add something to that? Rolando is really in the driving seat of the European micro optics revolution.
Thank you, Jose. Nice to be here. I was pleased to see all the discussions in the chat going around mastering and what are the bottlenecks for the value chain for imprinted micro-optics, but also nano-optics. And as I was trying to explain quickly there, in Fabulous, in the pilot line that we are currently building, will address all the bottlenecks in the micro-optics value chain. And I'm curious to see what Paul will tell us from Joanneum, who is one of the partners on Fabulous.
And the third revolution, Bedwyr. So I want ASML to be in the driving seat of all these revolutions. The third one is UV sources. And on this, you've been an expert, a user expert of many years. But right now, because a completely huge market demand that is coming because of the current world situation, we're seeing companies in the EUV and in the UV, developing really fantastic UV sources. So that's why I asked my friend Jennifer to be with us today. Jennifer, how are you doing today?
I am well, thank you. Can you hear me?
I hear you very clearly. When I asked you in the disinfection meeting, I asked you, what do you think of lithography? You said, wow, in lithography, there is a lot of UV needs. What do you think of the meeting, and what kind of cooperations do you think we should start with Bedwyr and the other companies?
Sure. I mean, there's, you know, in terms of printing and lithography, I mean, it spans so many industries. I mean, UV curing has been used for decades more on the commercial printing, label printing, packaging industry. But I think as we move more into UV LED curing technologies, there's probably going to be a lot more opportunities on the electronic space, especially as the chemistry gets more and more in the nanotechnology sphere. I think there's going to be an overlap. So I'm interested for two ways. I'm interested in all of this technology because we're using it as we build our UV LED curing systems, but then also looking for opportunities on these applications where maybe photopolymer chemistry cured with UV LEDs or the conventional mercury-based lamps might have some opportunities and some ancillary aspects of the application.
There are a lot of those. You're going to be amazed on how many introductions I'm going to make after this. Benjamin.
Yes.
Yes. Excellent. What's on your mind?
I'm using this the whole day, and now it leaves me alone. Thank you very much. Great. ASML, I mean, awesome to have them here. I have a question for ASML as well, but I would like to start with Reinhard because he had such a nice talk. And I heard that if the mankind wants to follow Moore's law, then lithography has to keep us the door open to not come to the end of the road. Reinhard, can you comment on that? What do you think? Where is the limit? When is this? When Moore's law is over?
I guess there's no limit. There were people saying 1 micron is the limit. Now they say 5 nanometer, 3 nanometer atomic scale. But you have to see that Gordon Moore, who's still alive, he changed his Moore's law himself. So after some years, he changed it, and now we have more than Moore. And I would say there's no limit for electronics. At least not in my lifetime. We will get it smaller, densely packed, more intelligent. Now, what is for me the most amazing is artificial intelligence. You know, when I studied physics, there was this neural network, we did optical computing, all bullshit. But now we have dedicated artificial intelligence chips in our smartphone, and we get more and more of these chips. We have a total different architecture, parallel processing, massively, totally different. So we will invent maybe not smaller than 1 micron, because then you're an atomic scale, but otherwise microelectronics has no limit.
Nice. And for ASML, I mean, the EUV tool, as Jose already mentioned, is absolutely stunning, amazing, outstanding. But because I'm doing process development in mass production, I want to have some questions about uptime and about how often you have to change the collector or the mask, how easily it will, because I think everything is there with reflection probably, and also the mask probably will be hardly attacked. And are there any issues? And roughly uptime, also the maintenance. I mean, do you have a certain team on site on, let's say, Intel or Samsung who's just maintaining the EUV unit, or how can I consider that?
So the tool is clearly highly supported when it's in the field. But I guess one of the points that I wanted to make in the presentation was that, let's say only a few years ago, we had productivity of maybe less than 70 wafers per hour. And when you look at those sort of numbers, then it doesn't make any sense to introduce EUV versus multi-patterning approaches. But it's all about bringing that productivity up in terms of wafers per hour, which is ultimately amortized over the whole year. So including the uptime that the tool has as well. I can't really comment on the actual uptime of the tool at the moment. That changes on a daily basis, and clearly it's all about improving that. But in terms of bringing one of those tools into your fab, then you get a huge amount of support, because I think what I've learned from being at ASML is it's all about supporting the customer. It's a focus on the customer's needs. It's a focus on the customer's roadmap. We're not here just developing tools because we want to get to 5 nanometers or 3 nanometers or a reduced resolution. It's because we're meeting a need. And when you meet that need, you then have to make sure you get the support in place as well.
I have somebody with the hand up, Rolando.
No, it was a mistake, Jose.
That's good, because mistakes happen to make sure the meeting continues on time and we go to the next speaker. And I anticipate a big discussion about replication after this presentation. I'm going to go to Austria, I'm going to go to Graz, and I'm going to go to a big supporter of this epic adventure that we're putting together. Paul, thank you very much for being with us this beautiful afternoon. The floor and the attention of everyone is yours.
Thank you very much, Jose. Can you see my slides?
Perfectly.
Great. I'm not talking about semiconductors. So I'm rather looking into our research in niche markets, and just want to start maybe with two different parts where Joanneum Research, as a research and technology organization, is using different types of lithography. Let's put it first a simple way. So we always handle simulations. So simulations are of course important to calculate what you want to do later on. For example, for microfluidics or for optics, we have to do hand-in-hand simulations, which with all the structures that we want to make out of it afterwards. And then we are taking care of the mastering process with two different basic techniques. One is the maskless grayscale laser lithography based on a self-built machine. And the other one is two-photon absorption lithography if you want to go to even higher resolutions. So once we have ended up with a small master, maybe on a 6-inch silicon slide with maskless grayscale, you can do a replica molding with a soft lithography, and you end up with soft substrates having these structures. And then, for example, you can go via galvanization of molds and end up with maybe already final injection molding molds for MicroOptics, for example. So this is a nice lithography value chain that can be used for many products already, apart from the semiconductor industry, of course. So if we change the right side of this image, we can also go in another way to reach more volume and other processes. So once we have a 2.5D master, for example, for optics, we can do the step and repeat process, well-known process from semiconductor industry. Here we had a very nice cooperation with EVG, which is also, Martin is also here watching, and I'm appreciating very much the cooperation that we had to get a step and repeat machine for not for 8-inch wafers, but for a 30 times 70 centimeters square that we are using at the end of the day to wrap around rolls, which are used with nano-imprint lithography on a roll-to-roll basis. So I go into a little bit more detail how we do that. So this is a continuous process which ends up with some structures that you can use for many different applications, apart from optics, also tribology applications or security features of banknotes, of tickets, of monies, and so on. So this is, again, an image to the left how this is working. So we are using also UV LEDs for this curing process, and it works fine. Here you see the image of the cylinders and some examples of holographic shims that we are doing. And here is the resolution. So we can achieve, for example, an aspect ratio of 5:1 at a critical distance of 200 nanometers with web speeds up to 30 meters per minute. And our machine is not so wide, but we have widths of 280 millimeters for research purpose. What you're going to afterwards is, for example, also to do metal grid evaporation. So if you want to get transparent electrodes or something like that, this could be a nice point to start with. Key of everything is a very delicate consideration of all the materials and processes inside. So we come with a very good quality from the design over the mastering to the step and repeat template. And here you get a electron microscope image of the quality of such a freeform micro-optics, for example, which you can then use to be multiplied. One of our USPs worked out together with EVG is the kind of a seamless stitching process, that you can do one portion after the other with almost no visible edge in between all these single imprints. Here, the grayscale lithography plays a major role. So we have this is our working horse, more or less, for the optics imprints. We use a UV laser of 375 nanometers, and still we can get the feature size down to 200 nanometers at aspect ratios of 4:1, it should say. One USP of us is also that we can produce structure heights of 60 micrometers. Here you see some measurements, that this is done at a very good quality. Here there is an example where you can do micro-optics even on curved surfaces. So there are not many applications for that, but if you have a diffractive structure, for example, on a curved surface which is refractive, this is not an easy task to do. All right, so the second mastering process is the two-photon lithography. Here the principle, and here's some examples from optics and microfluidics. This is a process now already brought forward by nanoscribe and multiphoton optics, which you hear maybe later. But we use a spectrophysics laser with 30 watts and different other performances in the femtosecond region up to 10 picoseconds for this two-photon mastering. Finally, here's some results of the roll-to-roll UV nano-imprint lithography pilot line that we have already achieved. So here you see some moth eye structures, or these are other structures from nature. Or here I showed you already some gratings and some pillars here that are typically produced with this imprinting technology. Well, finally, we are a research institute, and we are well embedded into the European projects that are able to support R&D in that direction. And for example, we are partner of the ActFast 4.0, and also the Fabulous project was mentioned already here. There are also open innovation testbed projects and another ICT pilot line where our institute is participating. And the main features why we are always, or most of the time, invited to join these projects is our special expertise in this UV nano-imprint lithography and step and repeat processes, which are very much can be used here even for smaller projects. So if you want to do smaller projects with us, you can use these bigger European Union projects to get small projects, starting maybe with an ActFast project at the beginning. And next year for optics, the Fabulous project for freeform optics will be a very good opportunity to test prototypes and to develop products with this respect. Thank you very much for your attention, and I'm open to hear any questions.
Okay, thank you very much, Paul. A great presentation and great technology. Okay, so now can you tell us, well, you know, the big question, can you tell us what can the companies that are in the room do for you and what can do for them?
Yes, I think what we can do for them, I tried to figure out in more detail already. Well, we will need, of course, a lot of different use cases to demonstrate this technology to be viable for a lot of different applications. And still, these are still niche markets to a large extent. It would be also nice to see opportunities, how bigger markets could be addressed. And if there is maybe some bigger markets around there that need these things.
And Paul, okay, yes, user cases. But for example, regarding mastering, do you have any wish, maybe, I don't know, to have a smaller data? So do you have any, yes, in your wish list?
The wavelengths is maybe not the decisive problem. I think the height of the structures is sometimes a challenge. So if we want to go, at the moment we're limited to 60 to 100 microns. We could go even bigger for optical applications and for microfluidics. So if we have some better technologies to go to 200 micrometers or even 300 micrometers in height, this would be very, very interesting.
Okay, because the Zoom chat is like on fire, so maybe it's a good moment for Mark from SEAL. Mark, hello, are you here?
Hello, yes, I can hear you.
Because you had interesting comments. I can read interesting comments from you regarding the resolution. So would you like to comment on that?
Yeah, well, we're working there's a lot of, say, traction and interest from the AR, VR field and the meta services. So in the end, where our customers would like to have 300 millimeter master wafers with feature sizes from 20 nanometers up to maybe a couple of microns. And well, currently the choice for mastering is just a single E-beam, and that takes forever to fill a 300 millimeter. So I had really good hopes for a mapper, but that now got absorbed by ASML. And as I understand, this is being used for inspection now. Then we have in Austria, IMS, but they have this multi-E-beam lithography system for masks. So I'm really looking forward to having, say, a foundry who's offering E-beam business using a multi-E-beam writer. Because for optics and basically the sub-diffractive optics, you need very high resolution and very low roughness. And currently what I've seen from, for example, 2-photon lithography, it's the roughness, for example, is too high. And also the throughput is really low. It's also a single laser that is writing it. There are no options for multi-beam, multi-photon for pattern generation.
And why are there no option for multi-beam, multi-photon? Ruth, this is something that you want to develop in the future?
Actually, we do a lot. So since more or less 11 or 12 years, when I was still at Fraunhofer, we started already multi-beam. And we do a lot of multi-beam lithography with our equipment for our customers using DOE or spatial light modulator.
Okay, so we're going to put a multiphoton machine there in Eindhoven at the skill. Mark, give us a challenge, because we can give you multi-beam, but what is can you give us some numbers in terms of resolutions or surface roughness?
Yeah, so dependent. So surface roughness is typically not an issue because you can go very low with the surface roughness. So the question is, when you go to, let's say, meta optics with nanostructures, whether the term roughness is useful or makes sense at all, because how will you determine that, in fact? So you determine that by the function of the device you create. And we calculated about with the present light source we use and going to the nanostructuring regime, which we do, about 4,000 to 7,000 beams might be possible, and then we need to switch the light source. That's it. So we switch the light source, we get more.
So for me, one of the biggest problems I have with the supply chain today of replication is perhaps the time that takes for the master to be from the design until you get it in your fab. Is that something as well, Mark, that you are trying to reduce? Do you have enough mask suppliers that develop the mask timely to you?
Well, especially for the meta services, yeah, it's roughness or it's really the absolute size what counts, and then you have to take in all the processes. So you have the E-beam, you have the resist, and you have the hard mask, the deep etching, you have the replication, maybe another etch step. And you need to do all these processes and then determine the transfer mechanism or the transfer function from your design to the final product. And well, that is really a challenge now. To get these loops short enough and in a short enough time.
So I know some very, very good people with E-beam in Scotland. They are called Kelvin Nanotechnology. If you want, I can make an introduction. They are really, truly fantastic. But I'm going to ask now the R&D partners that we have in replication, which are Joanneum and AMO. First, Joanneum, Paul, is there anything, any room for collaboration that you see here with Mark on his challenge?
Well, I think we have to talk about this in detail. I mean, we are not using e-beam for this purpose, because for the products and the customers that we have, we don't need this very high resolution. So in optics, for most of the applications, it's sufficient to go with optical mastering technologies by far. Although we do have an e-beam device in our laboratories. Yeah.
Any further question on this? Yes, I'm going to Amplitude. I'm going to France. What's on your mind, Quentin?
So we are actually laser maker on our side, and I was listening to the exchange regarding two-photon absorption and the multi-beams option that we could have on the table. And I had a question regarding the pulse duration, because when you talk about this two-photon absorption and the different option you have for making multi-beams using DOE, for example, or SLM, do you have like a preferred direction towards the real pulse duration that you're looking for? Is like the range of 300 femtosecond is sufficient, or you see some positive effect regarding the material if you go a bit lower than this?
At the moment, our lower limit in two-photon absorption is 400 femtoseconds, and we get quite good results. So the machines that we have are quite tunable up to several picoseconds, and also in wavelengths we can choose between 1060 and frequency doubled and tripled. We don't see at the moment a requirement to go to even lower, even shorter times. I have to say, okay. But maybe for some applications in the future, this may be the case. Yes.
So now that we have started the meeting, I'm going to call the attention of our users today, companies like Dencon, of course, Wave Optics. I know the Huawei people who are behind the lines. We are going to go to one of the coolest lithography machine suppliers that I have in Europe. We're going to go to Heidelberg Instruments. I cannot wait anymore. Thank you very much for being with us, Steffen. The floor and the attention goes to your maskless litho.
Thank you very much. First, I would like to thank the organizer. I have to share my screen. So, can everybody see my screen? Yeah? Okay. My name is Steffen Diez. I'm CEO from Heidelberg Instruments, and Heidelberg Instruments designs and produces laser lithography systems, also known as pattern generator, maskless aligner, laser direct writer, mask writer, and so on. So many different names for the same technology. And we do that since now more than 30 years. So our biggest strength is our extensive know-how in developing customized lithography solutions. We have 240 employees and around 160 in Heidelberg, here in our headquarters, from which 50 are dedicated to R&D only. And in addition, we have a worldwide service network. And in 2018, we extended our portfolio by acquiring a Swiss company called Swiss Litho, who are doing nanolithography based on a thermal scanning probe technology. And this year, actually, we will install our 1,000 systems, which is a big celebration. Probably we cannot really celebrate because of Corona, but we will try somehow. Here you see an overview of our product portfolio. You see on the upper left side our photomask writer, the VPG and Ultra system. The VPG is a very fast laser writer which can write structures down to 0.7 micron over an area of up to 1.4 by 1.4 meter. So the large photomasks are typically used for flat panel display, but there are also other applications in the field of MEMS, electronic packaging, photonics, and so on. So our largest VPG has a footprint of 6 by 8 meter, a weight of around 24 tons. And the moving mass, the substrate chuck, has a mass of around 1 ton, and we still can achieve position accuracy of less than 100 nanometer. So below here, you see actually our latest photomask writer. It's called the Ultra system. It's a semiconductor mask writer for the 180 nanometer node. And the big challenge here is actually to achieve submicron features with a uniformity of better than 20 nanometer. On the lower left side, you see the DWL systems that are our tools for grayscale lithography. Grayscale lithography already has been mentioned. It's a technology to create topographies in thick photoresist. And then typically the resist mold is transferred to by electroplating into a metal master. It's one of the key technologies for micro-optics, like for DOEs, diffusers, reflectors, holograms, and so on. And the DWL is using a special light modulator, and in combination with our electronics, you can achieve up to 65,000 different intensity levels. On the right side, you see our tools for fast microfabrication, the maskless aligners. They have been introduced in 2015, and we celebrate this year actually the 100th installation of a MLA 150. So it's a big success for our company, and we continue with the development of these tools. We introduced last year the MLA 300, which is an industrial version of the MLA 150. Which has a much higher throughput, but also full automation and the ability to handle also very warped substrates. And on the upper right, you see the nano tools based on thermal scanning probe lithography. Interesting here is also that this technology can be used also for grayscale. It can produce structures down to 8 nanometer. I mean, the throughput is quite low with one tip, but you can actually create also arrays of this tip and then have a much higher throughput, which will be probably also higher than most of the e-beam tools. So that was what we are doing, providing. So still, if you talk to people about UV lithography, more than 90% think about mask-based technologies like mask aligners and steppers, especially in the industry sector. And that's why, in my opinion, when microfabrication engineers, try to find solution to that problem, they don't take the possibilities of maskless lithography into account. And you see on the left side a sketch how maskless lithography works. So you see it's a serial process, which means obviously the disadvantage is that it's a slow process. But the big advantage is that you can control many parameters for each written pixel, field, or stripe. You have a spatial light modulator, which can actually change the intensity for each pixel or for each field, which allows you, for example, to compensate distortions from optics or from intensity distribution over the device. It's also a key enabler for grayscale lithography by changing the intensity for each pixel. We have a focusing length, which allows us to define actually the Z position of the optics, which we use actually to follow the Z position of the substrate and compensate for thickness variations or substrate variations. Then we have also XY stage, which can very precisely position each image or each scan precisely. So there is a lot of possibilities by controlling and changing these parameters on the fly. I mean, one of the most obvious things is that you can change actually the design you want to write, which we use already for serialization, labeling, but also for multi-layer alignment. But in my opinion, there must be much more possible applications. And I fear that many of our customers don't really know about what we can actually do. And so that's actually my request to this community. I mean, to think, I mean, how these possibilities can become new applications. Yeah, so that's the end of my presentation. Thank you very much.
Thank you very much, Steffen. Great presentation. Okay, so now let's go for what do you think? What kind of collaborations are you looking here in this meeting? No, for your, I mean, in order to improve your maskless equipment.
Yeah, it's basically not really to improve our systems.
Not to improve, maybe to for the next generation of devices.
Yeah, it's also that just the customers, the users of the tools, I mean, are aware that there are many possibilities besides the standard patterning what we are doing at the moment, and that's actually what I think there's a big potential.
Okay, maybe Ruth has a comment.
I actually do not have a comment, so hello, nice to see you again for years.
Oh, we have a question from Bedwyr from ASML.
I was not done with my question. I have a question.
Go ahead, please, Ruth, and then we go to Arseny.
Steffen, you mentioned the autofocus system you have in your system and to follow the topography. So what is the typical, let's say, resolution or sensitivity you have? What is the accuracy?
So we have two actually types of autofocus system. One is based on an air gauge, and the other is an optical autofocus. And optical autofocus is more precise, and here we can compensate around 50 nanometer variations, with a resolution of 50 nanometer variations, and it can follow up to 150 micron changes actually in the topography.
Thank you so much.
Okay, thank you. And now, Bedwyr from ASML, if you want to proceed with your question.
Yeah, sorry, I didn't want to jump the gun there. I was wondering, Steffen, is the tool able to carry out what I've called on-the-fly modifications to where it's applying the lithography? So if there's something underneath that's been misaligned, or there's something that isn't in the right place, can you carry out that on the fly, or at least you can put that model into the system and then print a modified pattern on top of that?
So, I mean, both is possible to do it directly on the fly. If it's just correcting a position, I mean, we can do that actually by applying a correction to our XY stage. So that is one possibility. If it's really a change in the pattern, then at the moment it's not really in real time. So there is a time you need to refracture actually the data. But what is a good example for that is in the wafer level packaging. You have applications where you have to align actually every individual die, and you can measure it offline and then compensate it by refracturing before you print the wafer. So that's one actually very nice example. But
that was the example that I was thinking of maybe RDL last advanced packaging.
Right. Yeah. So I mean, it's not impossible to do that also on the fly. It means to put more effort actually on the hardware to really fracture in real time. It's not impossible, but at the moment we don't have that yet.
Okay, thank you.
Okay, thank you very much. And then I think Kemi from Edgewave has a question. And also, well, take advantage to introduce your company.
Yeah, good afternoon together. I just one question, and Steffen, and what is, can we use your DWL system for make lens arrays in fused silica or other glasses?
I mean, not directly. So, I mean, we always create a resist mold, but then, of course, you can transfer it to fused silica. So that, yeah.
Transport to the fused silica is quite difficult. It means like you make tools, and then you make molding process like this, or what is next step?
Right. Basically, that you create a topography. Micro lenses in the photoresist, yeah, and then you use etching to transfer it to a fused silica.
Okay.
We have processes available with up to 100 micron and resolutions down to 300 nanometer.
300 nanometer, okay. And this works with a fused silica, and that's maybe also another kind of glass, right?
Yeah, so that
some specific glasses works where?
So that is actually not a problem of our tools. I mean, we can create topographies on all materials. I mean, there have to be some flatness, but then it's a question of the etching to transfer to the. And I think there are a lot of processes for many different materials.
But the etching is not you are doing now.
No.
You just make lithography.
Right.
Exposure. Okay.
That's right.
Okay. Thank you.
You're welcome.
Okay, and finally, we have a question from YouTube. So thank you, Pierre-Marie Coulon from the University of Graz, right? So it's a question that is 3 questions in the same sentence. So is any of your tools incorporate several lasers? So any of your tools can incorporate several lasers? If so, how much? If not, will it be an issue?
Yeah, actually, we have the MLA systems can use several lasers, 375 nanometer and 405 nanometer. You cannot use them in parallel at the same time, but you can, yeah, for each exposure, you can basically choose which laser you want to use. Yeah, so that's.
Okay, so I hope it answered the question. Okay, so then I think it was a great discussion. Let's move if there is no more comments or questions. No, okay, let's move to the next speaker. So Ruth, Managing Director at Multiphoton.
Hi there.
Would you like to share your screen?
I will do in a second. Okay, here we are. So can you see the screen?
Yes.
You can see the screen and you see the laser pointer. So finally I got that. So thank you very much for giving us the opportunity to talk about beyond conventional lithography in this meeting. So here's our product. This is a 3D lithography machine. And let me just get you some of the history of my background and the background of the company. So we started with mask aligning, with fabrication of fan out elements, for example, or single mode, multi-mode components up to 6-inch, and followed by UV assisted replication. So this was actually done in a common collaboration in a project called European project called Donderdam. At the time at Fraunhofer, was awarded by the Stifterverbands award. And we did many different things on coupling, on VCSELs, on wafer scale, and so on and so on. Something about projection lithography, and now you might think also waveguides, and now you might think, how come does that come into play with the lithography, what we are looking today at? So laser direct writing was done at Fraunhofer already at a very early stage. So that was at 256 and 528. And In the year 2000, we started with maskless lithography together with partners at Laser Center and Joanneum Research. And then we moved to build our own equipments because it was quite clear that we need equipment for fulfilling B2B requirements. And that is what we do now as a company for several years, doing maskless lithography equipment, laser direct write equipment, following a 2-photon process, but also following other processes. So here you see, coming with an idea, you can either go to the additive mode, which is the standard lithography mode, but you, aside of going only planar, you also can do 3D, which is shown here on this different micro-optical lenses or macro-optical almost lenses. Did a first metal printing with the machine. Then you can do standard lithography like subtractive fabrication and so on. But you can also use it as metal ablation tool for thin films, and that is from a customer project. And what we also pronounced as other, which is other is a very miscellaneous word, is there are many other processes which you can actually initiate with the machine. And here is an example on a short photoround glass, which we did. So this all can be combined with any of these above mentioned processes. And it's very, very good that we have demonstrated last year that we were fabricating a meta-optics, which was working, and meta-optics arrays, which typically done is by E-beam and many, many different other processes in order to create the function. And we did this, and it was done in 10 minutes. So that was quite cool. But we still need to improve that, but we have many customers already asking for that and customers who do that. So here is what is beyond the conventional lithography is that you have many special features which you have not in a standard lithography equipment, but which can be combined. If you combine the method, for example, that was what I just mentioned, doing ultra flat optics. So this example is about 1.1 micrometer. You can go wafer scale optics. So this, what we did is up to 6-inch. So at Fraunhofer ISC, there is an equipment with 300 millimeter stages. Then you can do extreme aspect ratios. So the example is 16:1. We have demonstrated 43:1, and it's probably much higher, but we are not an institute, so we skip that for the moment. We have demonstrated that you can really cut down the processes to amounts of 3. You can do automation, so all machines run 24/7. You can do very complex structures. So this is actually with Joanneum research. This is a very old image, but customized now for other customers. High throughput. So this example is from 2017, and that was 1 to 5 seconds per lens. So of course, if you ask me about the speed, it's always related to the structure, to the structuring mode, and to what we do with our software. We upscale that for bone cartilage methods. So this is almost a centimeter, but we have demonstrated more than 1 centimeter, like up to 3 centimeters. And work on arbitrary substrates. So this is an example of Nano Plus. And the resolution can be below 250 nanometers. So that is from an example which we produced in-house. So we are not allowed to share customers' examples. So this distance here is about 250 nanometers. So you see there is still enough room here. And that was a 2:1 aspect ratio. And I think that's it. And I'm exactly 5:30. Yes. Thank you so much.
Ruth, you're my star. Always start on time, finish on time. I'm so sorry I interrupted you. I would never do anything like that anymore. Ruth, you're going to get the epic question. Do you know what that is?
Yes. What can I do for you and what can the others do for me?
That's correct.
What can I do for you? So what we do with our customers and partners, also in let's say, in the way that we subcontract also people, and we are subcontractors of others and suppliers to others. We would like to know your design ideas and the challenges of the design ideas, because we always can work with something, but we are actually here to boost the limits of speed and of function and of capability. So it's always much easier to develop something if there is something in the background which is useful, because we are not here to do useless things, because we are often asked to do 1 cubic millimeter or 1 cubic centimeter of a device. So you take a printer, a 3D printer, and do this. So this is not scope of what we do. So what we offer is much, much more. And I would like to go back to the roots, into the, let's say, the lithography combined with our vision system. So we have an alignment system also to do the automation in the 2D up to the 3D and even the 4D space when it comes to biology, for example. That's very important.
Well, let's do something cool now. I'm going to go to my friend Arseny from Wave Optics, and I'm going to ask him to challenge you, because he's good at that.
Nice.
Give us a challenge, not just to Ruth, to the whole community. You are a star on the manufacturing of light guides, and I want people to help you because you're a success story of Europe. Give us a challenge.
Thank you, Jose. I'll be covering this in my talk, but our nanostructures are demanding, because we need resolution below 50 nanometers with a precision around 10 nanometers of tolerance and deviation. And we found that it's really challenging. So I'll be showing our manufacturing cycle, and I actually very much with Mark from Skill, and I think we're in a different league together with metamaterials, because our requirements for precision and the complexity of the shapes is at a different level comparing to micro lenses, for instance, and other micro optics, and it's really challenging, basically. So there are many interesting solutions for lithography we discussed today, but to be honest, I don't believe there is anything else than e-beam right now to address those kind of structures in nanophotonics.
And your problem with e-beam is speed.
Exactly, and we need to fabricate 200 and 300 millimeter masters, and because we do AR devices, we need to have the full length of AR glasses covered with nanostructures, so you can imagine the scale. From the same scale, you are getting, like in semiconductor industry, you are getting probably thousands of CPUs or RAM and so on. For us, it's a single device, basically.
The challenge is here. All EPIC members have heard it. 50 nanometers, 10 nanometer error. I think there are many people who want to help you, and I would like to make introductions. I'm going to go now to the semiconductor company. I'm going to go to Benjamin. I'm going to go to Infineon. Benjamin, we had this meeting on lasers for semicon. It was very interesting. We actually made many connections afterwards. Thank you for following up. You have seen now a lot of technologies. You have seen the maskless litho. You have seen the volume replication in roll-to-roll. You have seen, of course, ASML. You have seen the what challenges do you have for these people? At least one challenge, so I can work with that.
Yeah, it's a good question. I mean, the resolution for the classical excimer laser, they still work pretty nicely. And as you can see, ASML is, on top and then giving us smaller and smaller resolution. I think now with this 36 nanometers, we're doing pretty fine. But you never know what the future brings. But I have, really a lot of interesting stuff noted down, but not directly one question now to address. But thanks a lot, Jose.
I just want to say that after the previous meeting, I made, I think, 12 introductions for you. One person went to visit you afterwards. We posted something in LinkedIn about this. You are a star, Benjamin. Thank you for being at these meetings.
Thank you.
I would like to now say hello to a new friend, Jan Heringa from Dencon. It's their first ever EPIC meeting. Thank you, Jan. Goedemiddag. Thank you for joining this meeting. We have seen a lot of lithography technology so far. I'm interested on what Dencon sees as a business for this meeting and what kind of connections we can make for you.
Everybody, welcome. Hello. This is Jan Heringa from Demcon. First meeting with you guys. Would like to have a short introduction for Demcon. We are, let's say, a design, engineering, and assembly partner for, let's say, quite some OEM industry. And we specialized in, let's say, optical, mechanical, and mechatronics systems and sub-solution and subsystems.
This meeting is about cooperations. So
Yes.
here we have people who make lasers like edgewave, people who dedicate their work into making fantastic optical adhesives like Delo, people who are really good at filters like Fujifilm, like my friend Senija. Give us a challenge, just one Santa Claus Christmas list item that I can help you with.
Well, we are looking for challenges in this playing field, more or less, and yeah, we would like to be in contact with some of you guys to see what the challenges are, more or less, because we are, let's say, a specialist with our engineering group of 600 people who can supply services into all kind of organizations, including, let's say, some people here on the line.
And from new friends to new friends, I have knocked at this door, at the KLA-Tencor door. I have knocked for many years through different entry points. It was difficult, but we managed. We couldn't have a meeting on lithography without KLA in the room. KLA is here. Shlomit, thank you very much. It means a lot to have you with us. Thank you very much to be in an epic event, first epic meeting for KLA. I hope the first of many. We want to help you. It's a group of friends. As you can see, we are very friendly. We want to help each other. We want to help you. Tell us how to help you. The floor and the attention of everyone goes to KLA. I'm so happy to say this.
Thank you very much, Jose. Can everyone see my screen?
Yes.
Okay, 1 second. Oops. Okay, hello everyone, and thank you very much for joining. My name is Shlomit Katz. I'm speaking to you from Israel. I'm an application development engineer at KLA Corporation and part of the optical metrology division. A little bit about us. KLA was founded in 1976 at Silicon Valley, California. It has grown to become one of the leading companies in inspection and metrology solutions for the semiconductor industry. Today, we have over 10,000 employees worldwide, and there are over 57,000 KLA tools installed at global customer sites. We have wrapped up 2019 with an all-time record revenue of $5.3 billion. And the reason KLA is so successful is because we understand we cannot compromise on quality. This is why we have invested $2.5 billion in R&D over the last 4 years. It refers to both hiring the most qualified people, partnering with the best suppliers, and investing in hardware, software capabilities, smart algorithms, and overall tool performance. Our customers are the leading semiconductor manufacturers around the world. Our capabilities helped in creating final products, such as your everyday laptop and smartphone, but can also be used in other markets, such as the automotive and Internet of Things. And in general, any smart component that you have in your possession, keep in mind that it most likely went through one of KLA tools during its manufacturing process. And finally, what exactly is it that we do? KLA provides process control using inspection and metrology. I really like this slide because it represents very vividly what we do. So if we look at the inspection process, you can't fix what you can't find. All of the defects that are depicted here are basically units that are lost and cannot be sold. By using KLA inspection tools, the customer can characterize and find these defects, fix them, and by that, KLA is helping the customer increase their yield and profitability. Moving to the metrology portion, you can't control what you can't measure. As you know, the semiconductor manufacturing process has very tight specs and strict requirements. And by using our metrology tools, the customer can characterize the different features, make required adjustments, and by that, increase yield and profitability. I would like to thank you very much for your attention. I'm very happy to represent KLA in this session and hope you got a taste of what an amazing company it really is. Please use our website to learn more about our products and open positions. And also please follow us on different social media platforms. Thank you.
Thank you very much, Shlomit. Great presentation. Okay, so now, well, you know what I'm going to ask, right? What can you do for them and what can they do for you? So yes, what kind of collaborations are you looking here?
So I think any type of R&D collaboration in which we can get the latest technology wafers to our site at KLA Israel, measure different stages of the lithography process and see what is the next nodes and what is the next challenges that we need to solve and adjust our tools by.
Okay, maybe can you select one of these topics, the one that you think that will help you more?
I really don't have anything on top of my head, but I will make sure to contact the different partners when it's relevant.
Okay, thank you. So then questions, comments? Okay, so if not, let me introduce you one of the companies here in the room, Tobias from IMTech. Are you here today? Yes?
Yes, here I am.
Hello, how are you? Maybe can you introduce what is IMTech doing and what are your interests in this meeting?
Yeah, so MTech is working as basically as an integrator. Our customers, for example, are also involved in the lithography market. So basically, we are manufacturing or assembling modules. Or let me start differently. In a project, for example, in the lithography systems, these modules are produced by a lot of partners. So institutes are involved and different companies which are also joining or are members here in the EPIC community. And they all put together their knowledge and their capabilities of producing something. And when MTech steps in, it is in the part of bringing all that together to one functional module. So, which is then, of course, integrated on a higher level at the customer's machine.
Any kind of collaboration that you are looking for?
Yeah, of course. We're always looking for partners who are interested in our service. So especially if you have, we're basically not too much into mass production, let's say. But if it is difficult, if it's challenging, and if it's about complicated optics, electronics, and mechanics, that's a project we're very much interested in.
Okay, thank you. Jose, I think you
I have a question for Shlomit. It's the first ever KLA meeting, so I'm sorry if I ask something that I'm not supposed to ask. But for many, many years, we've been talking already about the 7 nanometer node, and it was very interesting. I think we have in Eindhoven worked a lot about how to actually take this to the next stage. But I would like to ask you, you said that you cannot control what you can't measure. What can you measure? And what is the minimum size that my friend from Infineon can use to monitor a defect? Are we talking less than 7 or is still not there?
So we generally measure around the nanometer scale. And I can say that the next generation of Archer tools that we are manufacturing OMD in Israel, they're going to be real game changers with huge improvements to be able to measure and overcome all of those different challenges and difficulties. Yes.
I am very excited about that. Actually, I asked you because I knew that you were going to tell me that this is upcoming, but there is no spoilers here, right? You cannot tell us where this is going.
No, sorry. You'll have to wait.
I will wait. I will wait. And actually, on the next OASIS conference, I'm going to go with a group of EPIC members, and we're going to visit you because we really want to find out how to work together. Benjamin from Infineon, we are talking for many years already about the 7 nanometer node. Is the whole supply chain already there, or do you see any challenges still on the metrology, on the manufacturing, on the lithography?
Yeah, I mean, especially metrology, we're trying to improve all the time. I mean, I cannot say details, but also this week I was spending one day about checking different methods to measure one thing repeatedly with an reliable outcome. So yes, it's really an interesting topic, and it's good that you put Shlomit into the board.
Okay, great. So then comments, more questions, other things to add? Okay, if not, let's move to the next speaker. So Arseny from Wave Optics. Would you like to,
Yeah, let me just share my screen. Can you see it now?
Yes, perfect.
Okay, perfect. So let me just briefly introduce Wave Optics to you. So we are designer, manufacturer of waveguides and light engines for augmented reality applications. So more specifically, we do diffractive waveguides. The company was trading since 2014. We're a large startup, currently 105 people. We raised more than in excess of 60 million up to date. And internally, we've got specialists in many different fields because the product is quite complex. So we've got a modeling team with in-house developed tools, people who specialize in fabrication of nanophotonic devices, in metrology of nanophotonic devices, and of course we've got in-house optical testing capabilities. We are based in the UK, close to Oxford, with business representatives across the globe, including North America and Asia. I'm going to scroll quickly through those slides which are showing our products, because this meeting is not about AR, but mostly about lithography. But you can see from those slides that we've got a number of solutions for AR lenses with different field of view. And we've got a number of projectors which are paired with those lenses and specifically optimized to be used with those diffractive waveguides. This is a slide where I want to focus for this meeting because it shows our full manufacturing cycle. So we produce our diffractive waveguides using nano-imprint lithography, but for this, we need nano-imprint stamps, which we produce using e-beam lithography. We do them usually on 4-inch, and then for the mass production, we're using step and repeat process from EVG to create step and repeat masters on 200 millimeter and 300 millimeter wafers. And after this, we use imprinting from EVG to produce them on mass scale. They are then coated with functional optical coatings, cut into individual pieces, and then stacked into the final product. On the next slides, I want to discuss some advantages and disadvantages of both types of lithography. So for mastering, it's e-beam. You can see what we like about it on the left side, and some challenges or disadvantages on the right side. But in a nutshell, it's expensive, it's long, and we still can't fully fabricate complex 3D shapes with this technology which we require. The next slide is showing similar bullet points regarding the imprinting process. So with the imprinting process, what we like about it is that it allows to replicate complex 3D shapes on mass scale. But of course, there are some disadvantages which are listed on the right side, and summarizing them, it's in a nutshell, it's the control of the dimensions of the nanostructures and its optical properties of the materials which are used in the nano-imprint process and homogeneity of those materials. Now I'm actually coming more or less to the end of this presentation. I want to answer epic questions in advance. So in terms of what we can offer to our partners, it's listed here on the screen. So we do co-development in terms of bring up of challenging manufacturing processes together with our manufacturing partners. On the R&D side, we did develop a number of advanced metrology and nano-characterization techniques which are suitable for non-conductive nanophotonic nanostructures, and that's a separate challenge actually to do this kind of metrology. And of course, for our customers, we offer waveguides and light engines, and we believe that we do them better than anyone else. And the final slide, this is my wish list for the EPIC community. So you can read through the items of what we're interested in. On the nano-imprint side, we're interested in specific nano-imprint materials with confirmed homogeneity of the optical properties, high refractive index, And for the tooling, we are interested in producing 200 millimeters and 300 millimeter nano-imprint masters with a resolution below 50 nanometers. You can see the challenge on this picture on the left, because this is one of our imprinted wafers. You can see 10 waveguides and their dimensions. Approximately, they are each of them is 4 by 5 centimeters. And each of those waveguides is fully covered with nanostructures which have resolution below 50 nanometers. So in my opinion, it's extremely challenging to fabricate nano-imprint masters for such kind of scaling devices. And finally, in general, for the nanophotonic community, I personally don't think that we have suitable and fully tailored fabrication techniques for this kind of nanostructures. And the same applies to the nanocharacterization. So in terms of metamaterials, AR diffraction gratings, and other similar devices, it's probably a big way forward which we need to go through to establish those kind of technologies. Yeah, that's the end of my presentation. Thank you.
Wow, Arseny, you're my star. This is exactly the epic culture. I come here with a shopping list. Let's help me. Let's find people who to help you. Let's go to Karlsruhe and let's go to my friend from Nanoscribe. Henrik, what's on your mind?
Oh, thank you. Thank you very much. I just had a question regarding the aspect ratio for these 50 nanometer waveguides.
Well, the aspect ratio, I can't give you any numbers, but I can tell you it's not very challenging. Our main challenge is XY resolution, basically, and the shape of those structures in the XY resolution.
Okay, thank you.
And from Karlsruhe, we drive 1.5 hours south, and we go to Heidelberg. Steffen, what's on your mind? Let me unmute you. We have a question from Steffen. Yes.
Yes. So I would like to understand a little bit more in detail what are really the challenges for the e-beam mastering and why it takes several tries to create one master. Maybe there is.
No, it's not several tries. It's just the area which needs to be written, because it's a 200 millimeter area basically, and
so it's a question about the time to write it.
It's a question. The resolution is enough, and the e-beam is a good tool to provide this resolution. It's a question of an area and the cost, because the cost of writing this area is very expensive.
How long is typically the exposure time for 200 millimeter? Do you know?
I think we've got some e-beam lithography manufacturers here, and it would be better to address this question to Waypop, who is actually a user of this technology, but to some of the people who make these tools.
And what is the maximum height of the resist you use for your mastering?
Could you repeat this, please? Sorry.
Maximum height.
Maximum height of the resist. I can't share numbers publicly.
Okay.
Okay, so now we go from Heidelberg, we go to Munich. We go to Patrick. Patrick, what's on your mind?
Hi. Arseny, nice presentation, and definitely very impressive waveguides you have there. But what is the sweet spot for the pricing of these waveguides for a consumer application? So what is the cost of a single waveguide that you can have?
I mean, even if I could share this information publicly, I'm not the right person to ask this question, to be honest, because I'm doing R&D and not much involved in the commercial side, let's say. So I'm afraid I'm not the correct person to answer this question.
That question should not be answered in any case. But on Monday we have a meeting on polymer optics, in which we're gonna address that particular side. Although I don't want to promise we'll answer that question whatsoever. I am very curious, Patrick. Now that you said something, because he's talking about, let me share the magic slide of Arseny. So he's talking about resins for nano-imprint lithography and glass with a refractive index higher than 2.0 with low K. Is there anything that the companies in the room, companies of course like Delo, but we also have of course Fujifilm and we have Pivon, anybody can help Arseny with this? Patrick?
2.0 is a great goal we have. We have for our R&D guys, we're happy if we have something very reliable at 1.85 with a price tag that is consumer market capable, or which is somewhere in the range that people want to afford. So this is, I think that's the balance we have to have here, like the best waveguide you can have out there with the best specs, and at the same time a price point that is consumer friendly.
You know, I like surprising people. I had Chris, like always, like thinking, oh, what am I doing here? Inseto is in the room. First ever epic meeting for Inseto. Chris, thank you very much for joining. I really like your company, by the way. Can you help us a little bit here on this?
I actually was going to ask a similar question to Arseny, which was, does he think that he's currently limited in resolution by materials or by his equipment and his mastering? And if when it might change, when it might switch, if it goes from materials to equipment?
I mean, I guess we're not so much limited in the resolution. It's just the cost of the techniques and the precision of the techniques which are now available. Because, for instance, e-beam tools are very good tools to create masks for photolithography, or they're actually extensively used at universities for research, for creating single devices with high precision. But creating, like, for instance, nanophotonic devices on mass scale, it's a completely different field, requiring completely different solutions, in my opinion. And nano-imprinting is one of them. Martin from EVG, I guess, is doing a talk after myself on this, but it still needs, let's say, certain improvements, and there are some challenges as well. And one of them is the mastering process, for instance.
I meant more, are you limited by the resins for the aspect ratio and resolution rather than the equipment, or is it?
No, in our case, I don't think it's a limitation for us.
We have talked a lot about maskless litho. We have talked a lot about replication. We have talked very little about mask-full litho, if that's correct in any English. But I'm very happy that we have Bedwyr with us from Topan Photomasks. And I'm very happy that we have companies who can supply and companies who can buy to her. So let's try to find your challenges. Bedwyr, thank you very much for joining this meeting. I have you muted. Maybe we can try to unmute you. Yes.
Okay. Hello, everybody. Yeah, thank you, Jose. Yeah, I mean, what we bring, I heard a lot about maskless lithography. I don't like that. We'd like to see how we can help with either traditional photomasks on 6-inch, like quartz etched masters, or nil more on the wafer scale. But I think we have the technology from the photomask industry serving the semiconductor industry, if you like. So we have very high precision lithography tools and etching possibilities. And really we're trying to see how we can support all of the users here.
What is the trend? Are we still in the chromium time, or are we moving towards new ways of printing on the masks?
It depends. I mean, chromium is probably the main application or the main type of material that would be used for the applications here. Obviously, in the for the advanced semiconductor, there are other mask types being used. And also, our friends from ASML talked about the EUV. So obviously, the EUV mask is a totally different. But I think EUV would be a very expensive solution for, I mean, the kind of resolution you're, especially Wave Optics is looking for, you know, ideally that probably would be met with the EUV, but that's probably a very expensive solution for the application right now, maybe in future.
In the supply chain of photomasks, of course, you have the printing, you have the cleaning, you have the processing, you have coatings. Santa Claus Christmas list, this thing that you ask every year, and maybe the friends of Epic can help you with.
I don't know. I guess from you spoke, one of the team spoke earlier about the right time on e-beam. I think somehow to get better e-beam resists so that we can write faster, because we take a long time. And again, multi-beam writers are not yet there, and they're also an expensive solution. So I think resist development for e-beam could be a thing, but I'm not sure there's anybody here who can help me with that. But
I think we have a lot of people who can help you, and I have friends all around the world. I'm a very friendly person. I have friends at DMP. Naoya-san, thank you very much for joining today. You are a printing company, inkjet printing company, a fantastic printing company in the photonic sector. Can you help any of the members today, or can the members help you?
Yeah, actually, our company is also providing photomask for semiconductor and photonics. And actually, we have a multi-beam mask writer for photomask. So that currently we are making nano-imprint master template with resolution down to 14 nanometer and spaces. And the multi-beam mask writer has a quite good throughput, so that we can make full field of imprint template in a reasonable writing time. So that's one of the solution for your requirement, I think.
Indeed. Hayashi-san, I don't know if it's possible that you cooperate with Top and Photonics or no. I don't know if there is, of course, somehow you could be competitors, but I love when people help each other, because all of us working together is what makes this epic community a family. So I hope you find a way for at least having a conversation. Topan is a great company that we have in this network. Any other, Naoya-san, any other potential cooperation that we have for you in this meeting?
Yeah, basically, we would like to expand our mask business to not only semiconductor but also the photonics. So that as you talking about the imprint template kind of things is we'd like to provide and cooperate with EPIC members.
Fantastic. I think it's clear that you are going to find a lot of cooperations, especially my friends from Eindhoven, Mark Verschuren. I really think the two of you should talk offline. I hope that you can find some room for cooperation. I thank you very much, Hayashi, for joining this meeting. So far, it's been a fantastic meeting. I'm enjoying it very much. We're going to go to the last but one presentation. Almost everything that is great in life finishes. So we go now to the last but one. We go to Florian and Ing, next to a beautiful river. There is a place where they make fantastic semicon equipment. Let's go to the EVG group. Martin, thank you very much for being with us this beautiful afternoon. It's almost 5 o'clock. We have 35 minutes still for discussion. The floor and the attention of everyone is yours.
Mute myself. I hope you can hear me.
Hear you clearly, see you clearly.
Perfect. So thank you very much for the opportunity to talk about lithography and about the equipment we are doing there. And basically, I'm very happy for some of the previous speakers already mentioning some of our capabilities, because otherwise the time would be very tight. Just a brief look at our company. I want to mention here two things. So we have two things to celebrate this year. It's 40 years in the industry and more than 1,000 employees. So unfortunately, Corona stopped maybe the celebrations. However, luckily it didn't impact the business so far. There was a lot of discussion how the lithography moved the whole electronic industry, and also for Moore's law. Maybe here some of our contribution. I think our contribution to the Moore's law is in the third dimension, the biggest. It's the 3D stacking, the hybrid bonding for CMOS image sensors and memory. We are doing also laser debonding for thin wafers. We have a wafer bonding system for the front end of line, where I will be happy to see it next to one of the ASML tools, I think. And yeah, maybe also interesting to discuss if we could work together in this field. However, today it's about lithography, and there are two very new technologies we launched or new developments we launched. It's the maskless exposure technology we have, and the nano-imprint lithography that you heard already from Arseny a bit. Yeah, for the three methods that EVG generally is supporting, so we come from the proximity mask aligner exposure. It's for the very first products EVG was doing. Our founder, Erich Thalner, invented the backside alignment for mask aligners, and it was kind of starting of the business. It's fulfilled. Typical resolutions are right in the 3 micrometer range for the production. Now we move to the next level. We want to go for the maskless exposure technology to bring this to the back end of line, being more digital, to be more free in design. And of course, a big topic today, and also my main topic, UV nano-imprint lithography, where we have the step and repeat and the wafer level nano-imprint lithography. We can go to lateral dimensions. Right here, less than 30 nanometer. Actually, we have already seen single nanometer resolution and done it. However, for production, I think we are a little bit better than immersion at the moment from a resolution point of view. For the rest, maybe I think there are other parameters we have to look at first. Anyhow, to give you a glimpse what we can do and what we are doing, typically mask aligner lithography, we do all the things well known for many years in the market, from the Liga structures, bond frames, very high aspect ratio structures, to bumping TSVs, thin resist, obviously for etching, metallization, surface protection in the back end. Nice new application is we see black resist, colors resists in general for shading of optical modules. And of course, in the MEMS area, doing it's a very good technology actually for high topography. Mask aligners have a high depth of field view, and that's why you can also pattern cavities and can expose them. To our newer development, digital lithography. It's also a maskless technology where we really address here more flexible manufacturing in the back end of line, but also in the photonic industry, where you can really very individual work with your wafers. There was one question, how flexible you can address it on the wafer. So basically on the fly, I think it's also mainly the adjustment of the alignment at the moment. However, if there is a little pre-measurement, I think we are confident that we can feed this into the line as well, for example. This is one of the things, but more importantly, definitely is that we get a new level of manufacturing quality to the back end of line by this digitalization. Next thing we are doing, then we are in the UV replication mode, is wafer level optics. Basically, this was the first mass manufacturing technology for the imprinting we brought to the market, and there are small modules made for smartphones already for many years. However, it had quite a bit in recent years. There were some new modules coming out. It's biometric authentication, for example, 3D sensing. Those got very important. And of course, you need here the smallest, most precise modules, and therefore the lens molding is the best technology. Basically, what we do here, we use a puddle dispense, then we align a stamp with a certain structure, we bring it in contact, this very precise alignment, and then we can also automatically demold it. So it's a fully automatic process. And you can make here, as you can see on the right-hand side, also with our friends from Germany, Belo, here's some partnership work. You can see from the master to the lens imprint, very accurate imprinting with the materials with a very low roughness of less than 10 nanometers. So very high quality for this very small lenses. As you can see, we get very good shape accuracy, but also very important, we can do this with very precise alignment. That's very important for the modules. For example, when you look here, if it would be on an image sensor, we could hit the pixels and do the lenses on top, but that's very important nowadays. But also for the stacking, you need this alignment, which gets more challenging because the distances change. Our systems are optimized for this large gap alignment. And last but not least, and so we have even developed further from this imprint technology that's very good for components or molding on maybe image sensors. However, there are more advanced needs where you need nanostructures, very complex structures to demold. And here we have the SmartNil technology. The basic principle is roughly the same. You still have a stamp, you bring it in contact, you cure, and then demold. However, with this system, we have more flexibility inside. There's flexible backplane, which demolds much easier. And even more importantly, you have heard it from Arseny, we can scale it also to 300 millimeter, starting from a small stamp with the step and repeat, and then we can go really for the mass manufacturing, the 300 millimeter level with many different structures. As you can see here on the bottom side, with very high quality. Also the slanted gratings we can do on the 300 millimeter, as you can see here, one example. So all this is possible, and actually there are products out there. Arseny showed one, and I like it very much, and I hope I can own one soon myself. However, there are other things we're already enabling today. One is, for example, for advanced optical sensing. We work with a small startup called NanoLambda. They also were in the previous EPIC meeting. They do a very nice spectral imaging sensor where we do the nano-imprint on top of an image sensor. We get thousands of different filters manufactured on the nanoscale to get here the spectral filtering. Or we have novel biomedical sensors also based on optical principles. One of them is today out there to detect the COVID-19 virus. So these are things that can be done with the right design. Of course, that's not on us. We deliver the equipment, and we have a lot of technology know-how behind it. And yes, of course, you don't need to directly buy the equipment. You also can interact with us directly. We have our Photonics Competence Center to collaborate, to really help you get started with the technologies, to get access to state-of-the-art capabilities. And of course, we cannot do this alone. Arseny, for example, showed very nicely. It's always a process flow that interacts where we can do all the different steps. We need good masters, we need good materials, but also we need partners that can show that the other integration processes are working. And obviously, if you have nice contributions to our equipment, maybe laser sources, light sources, UV light sources, sensors, whatever, let us know. Thank you.
Thank you very much, Martin. It's super interesting presentation. Okay, so maybe then, well, you know the question, you already said something, but yes, maybe you can summarize. So what can you do for them? What can they do for you?
So basically, yes, as I already mentioned, so there's two levels. One is definitely this co-integration, working together to establish full process lines, get from very high quality masters to a final product, but also get the coatings, the etchings, whatever needed done, this kind of integration. Definitely, we want to bring this technology to a new level, to get it closer to the levels electronic manufacturing has today. And of course, as mentioned as well, on the equipment side, light sources, laser sources, things like that, sensors can always be of interest for us to improve the equipment and also to maybe collaborate on the metrology, for example.
Okay, so any comment, about this wish list that Martin presented now? Okay, if not, let me introduce you one company that we have here that, well, we can consider an end user, so maybe a potential customer for you. So Michael from AMO, how are you doing? Are you here, Michael? Yes.
Yes, I'm here. Yes, I'm okay.
Hello. Maybe can you introduce what your company is doing and what are you looking for in this meeting?
Okay, so of course AMO is still a company which is doing mostly nano and micro research, microstructuring research. And what we are mainly doing is really here we are using different kind of lithography tools. So this is a perfect meeting for us as well. We have, besides the classical mask aligner lithography, we have also interference lithography, we have nano-imprint lithography, we have stepper technologies. So that is why I'm here, and to get an overview about new developments.
Okay, and any of them, I mean, about the presentations that you saw and about the people that was talking about their companies, any potential collaboration you can see here, any potential collaboration?
Yes, of course. From the presentations, we already have collaboration with different companies here, and so it's also a well-known community for us.
Okay, perfect. And well, if you want to contact with someone, we will be very happy to make the introduction. Okay, so and now also, well, regarding the great talk of Martin, now I would like to introduce you another company that we have here. Also, you were talking about the lenses, about the coatings, and we have here Exenija from Fujifilm. Hello, I am afraid I didn't say your name correctly, but well, I tried.
Xenia, it's from Fujifilm.
Okay. Okay, maybe you can explain what is the interest of Fujifilm in lithography. What are you doing for this market?
Of course, Fujifilm is a big global company. I am a part of the Fujifilm Electronic Materials. We are producing of the chemicals for the semiconductor industry, and we are also entering the optical markets. We produce resists, different kind of technology. And in the room, I have, or we as a company have a lot of great customers and a lot of great collaboration partners. And we are working as a standard business, but also we are doing new developments with them. And I like EPIC meetings very much. Thank you for a great organization. I made from the previous one, I think it's my 10th meeting, and I made a lot of good collaboration, and I'm starting a lot of new projects thanks to the EPIC community.
Okay,
and from this meeting, my plan is to contact WaveOptics and also Heidelberg Instruments.
Wow, great. Okay, the connections. We will make sure that you make these kind of connections. Okay, so if there are no more comments or questions for Martin, we can move to our last but not least presentation, and also connected with what Xenija was talking. So we have here Patrick from Delo. Oh, very well. You already share your screen and presentation mode. Okay, so you can start, please, Patrick.
Perfect. Thank you. So I have to say a lot of thank yous now. First one to this guy and the whole EPIC team for putting this up. It's amazing what you do here. And then also thank you to Martin. Great presentation and directly putting the ball into my field here. We are Delo. We're about 800 people located close to Munich, family-owned business, but we have offices all around the world. So we have offices in the US, in Shanghai, and in Singapore. So wherever you are, we are there. We can help you. And the idea is to develop and achieve goals together. So we have a strong innovation focus. We're application experts, so we have focused fields and we want to be experts in that. And we're a premium partner, so we want to develop a process or a product with you from like the very first idea up to the mass manufacturing, and then also the second generation. And I've given that presentation hundreds of times and got somehow boring, so I wanted to put something new on the slides today. And Martin showed our lenses in the EVG tool already, but apparently we also have these photostructural materials. So it's not our main focus, but and as Reinhard said it, we're not where you need the most high detailed lithography steps. But if you want, for example, to do an imprint and at the same time do some photo structuring because you want to leave bond pads free, you want to have some special structure replicated, that it's easier to be done by light instead of a mask, so in contact imprint mask, then we have solutions for that as well. Another interesting thing that we're working on is inkjet printing. So inkjet printing is getting more and more interest in the community. People are going away from spin coating, looking at new technologies, reducing waste of material. And we have a whole portfolio with different optical properties of inkjettable materials, from optically clear standard refractive index 1.5 materials to high and low refractive index materials 1.6, 1.38, to black materials, low CTE materials. They're all fully solvent free, so no solvents in there. They work. We have a collaboration here with XAR. They're all proven on their print heads, and you can use them directly as they are in the print heads. Then Martin, you said you want to have equipment. Delo does not only offer polymers or UV curable adhesives and materials, but also equipment. We have dispensing equipment like jetting valves, but also light sources, spotlight sources, area light sources. And the same here, they're all customizable. So manufacturing and R&D is all done here in Germany, and we can customize that. I want to give you an example on that. Take the area lamps. So you have some kind of requirement on intensity profile, homogeneity of the intensity profile. So what we do is you give us that profile, what you want to achieve. We put it into our simulation, and then we give you a proposal of a lamp setup. We then put it together in our R&D lab. We do the measurements on this. And by that, for example, if you say we want to have this, this and that intensity profile, we can say, okay, use a 4x4 array, a 2x2 array, or use a single lamp and a special light hut to direct the light. So that's all possible here. It's all customizable. We do it here in Germany. And the best thing is, even when you take a standard lamp, we can do modifications on the back, not only the light part, but also the implementation part, like going from air-cooled to water-cooled solutions if your application requires that. If you need a more stable solution in your equipment, we can offer, for example, the water-cooled light array or lamp array for your equipment. Okay, so that's in a very, very short overview what we can offer. So we would really like to help you achieve innovation in your field by innovative products from our portfolio. So what we can offer is innovation on products like materials, UV curable materials, but also equipment. What we need from you is contacts, ideas, something to work on.
Okay, thank you very much, Patrick. Very interesting presentation. Okay, and I mean, in addition to ideas and user cases, what kind of collaborations are you looking for in this kind of meeting?
I mean, in the best case, something where you have an idea of using our materials with a new device concept. So if you say, okay, we need that lamp and that kind of material, they need to be tuned together to achieve something very new, very special, then we would like to work on that.
Okay, so let's see we find this kind of connections, because we have here John from the Dublin City University. Hello, John. How are you?
I just mute my audio. Hi, Anna. I'm sort of the gate crasher here. I'm like the wedding crasher because I'm from an academic background, so I'm not representing a company. My interest in all of this is that I was in laser plasmas and EUV light sources for a long time, and I left it for a while, and I've just come back actually to ultrafast UV and EUV sources, and I've just received some funding to do some studies in resist materials. So I was quite interested in Bedwyr's ASML presentation, because amongst the challenges, as Bedwyr will tell you, is the resist materials. And so that's really where I'm coming from and coming back into this lithography community. Also at DCU, we have a nano research facility. So we have, you know, nano and micro manufacturing along with microscopy and inspection and so on, and together with some other types of microscopies, new ones like STED microscopy. In fact, we have a nanoscribe in one of, so we do some 2-photon stuff with nanoscribe as well. So that's where I'm coming from. I think I'll make contact with Bedwyr after this, because I think this is I'd like to make a connection to ASML. I already have a connection to Intel and to people in Munich and so on as part of this new project. So the bottom line is, in EUV lithography, everything's going to happen in the first 20 femtoseconds. So you put in a photon, you produce a photoelectron, you get some secondary electrons, and that drives all the chemistry. So you have to control what happens in the first 20, 30 femtoseconds, and that's where we're coming from. So I come from looking at some of the fundamentals in EUV lithography. That's where I'm coming from. By the way, it's also nice to see Bree Connolly. She was I lectured to Bree many years ago when she was a student in our university. not many years ago, a few years ago. She just reminded me it was a few years ago. So delighted to see you, Breed. I didn't expect to be on this call. So that's me.
Great, our friends, new friends, right?
But
So
you have money. You have money to research on materials. We like that. We like that. Give us because I have any resin, any material that you need. I have it. So give me a challenge. Give my friends a challenge.
Well, there are probably so I'm not an expert on the materials. I'm an expert on the EUV and free electron lasers and so on. So my good friends who are more involved in the material side tell me there's chemically amplified resist, there's multi-hit trigger, and then there's the like Impria nano materials. What actually we're interested in is, and I can't say too much about it because it's Intel, but we are going to look at more future materials. And so I think the future for EUV lithography looks very, very positive. And we're hoping to contribute with the tools that we've developed and our expertise, contribute to it. So the challenge we put out there is show us your best materials and let us study the dynamics, electron transport and energy transport and ultra-fast timescale.
Any further comments or suggestions for collaboration before I start with my already announced final remarks? I would like to have some final remarks from 3 of the people at the meeting, but first I would like to ask Mark Verschuren. Mark, you are one of these companies who I always say, when you help Mark, you help me a little bit, because I really, really want good things to happen to good people, and you are one of them. Mark, a challenge for the supply chain. How can we help you be even better than you already are?
Thanks, Jose.
You know I mean it, right? You know I mean it.
Yeah, I know. Well, I think this community is helping. I hear the challenges. I hear from Arseny his clear put challenges on refractive index. I think it's not only the refractive index and the low absorption. It's also these materials have to withstand high humidity, high light flux, high temperatures, automotive environments. So there's really a long list of challenges. And well, if anybody has some micro or nano optical challenges that they need also special materials for, talk to us. And we're actually, we do tooling, but actually our main expertise is materials and processes. So
you
we
work
do processes for you.
You work really hard in setting up a skill, and the company is attracting a lot of interest. I want to visit you, and I want to come to visit you more often. Eindhoven is an amazing city. Let's stay in Eindhoven, and let's get some final remarks first from ASML. Bedwyr, it was your first ever EPIC meeting. I hope the first of many. What are your words of wisdom after these 2.5 hours?
Well, you're not going to get many of those from me, I don't think. Not in fact my first EPIC meeting, my first for ASML, but in previous lives I've attended many EPIC events, so I know the organization very well. I guess the comment from us is that the whole semicon industry, and certainly EUV, is so integrated that you need to understand what's going on in the etch, you need to understand what's going on in the resist in order to do the litho well, and vice versa. Everything is so integrated now, so it's about bringing us all together. And I've certainly made a note to get in touch with John. I've put my contact details on the chat as well, so if John or anyone else wants to get in touch, please feel free to do so.
This is so great. So now you're going to get a lot of emails, so be ready for that. Going to work very hard for us. And we are going to go now to the beautiful Caribbean beach of Neuchâtel, because I see there the palm tree and everything.
Change the background.
give us some final words of wisdom for this young generation of friends.
So I started my career with 7 years holography with dichromatic gelatin, which was the worst resist I ever worked. It was really a catastrophe. Photoresist is getting better. For the imprint, I would like to have better material. Patrick is working very hard on this. Needs to be stable. So the outcome is machines we have. Mastering is a problem, But the key to success or failure is the material. And the challenge we have is, I guess, all the nano-imprint companies in the world will not use more than 10 cube meter of resist per year or something. Huh? What do you think, Patrick? What is your estimation? So it means we have very low volume because it's only nano, yeah, and that is the real problem, the chicken and egg thing. But I'm very confident that we will master this and that we will have it everywhere in printed structures.
Is the metrology still a challenge you consider? No.
No, it's not a challenge. It's only if you run 200 wafers, you have a challenge. If you run 200,000 wafers, you can buy the real machines and you get a real solution. It is in lithography, you can get everything. You could get a 7 nanometer, 300 millimeter wafer with your nanostructures, perfect. But it costs you 2 million. And the wave optics and all the companies don't have the money to get it done in the fab. And the fabs won't do it for you because nobody will run one wafer in a semiconductor step for an external customer. So we have everything on the planet, but we have no access.
I think we have everything on the planet. We have the access. We have the 2-photon polymerization on multiphoton and nanoscribe. We have the direct laser writing from Heidelberg. We have the mask from Topan. We have the UV source, the UV sources from GW. We have the money on materials from DCU. We have the printing, the eject printing from DMP. We have the skilled tools from Margaret Suren. We have the R&D for roll-to-roll manufacturing in Joanneum. Of course, we have the optics from Opto Sigma, the R&D from AMO, the materials from Delo. Of course, we have the giant ASML, the equipment from EVG, for fabulous access to MicroOptics from CSEN. We had the material and the coating from Fujifilm and my friend Senija. We have KLA-Tencor in the room, ScienceGetter, Inseto, Amtech, Wave Optics, NanoPlus. Get in touch with each other. Keep connecting, keep being epic. I can tell you I learn a lot in every meeting. I learn a lot in this meeting myself. I took a lot of notes, but I'm just going to share a reduced version of that. I think that it's clear that in the photolithography, there is still a challenge for on the writing of the mask from multi-beam, and there DMP has something quite spectacular. On the mass lithography, we think there is a chance for multi-laser beam writing. I think both on the direct writing and the 2-photon polymerization, multiphoton, nanoscribe, Heidelberg, they have great technologies. On the nano-imprint lithography, we saw a key set of challenges from Wave Optics, and we all want to help you, so we'll help you, Arseny. I think there are two supply chain challenges. I couldn't really find a solution. First is the fast EV manufacturing services. I don't think we'll ever find a solution for that. The second, when it comes to going to the very, very high-end metrology, but KLA-Tencor told us, wait, we have something spectacular for you. And I can already tell you, I think they do. Thank you very much for this. It's 5:26. We finished 4 minutes before time because you deserve it. Have a great weekend and continue being epic. On Monday, Polymer Optics. See you then. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye-bye.
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 Bye-bye.